So here's another example. Find the Laplace transform of e to the k times t. Well, the Laplace transform of e to the k times t is the integral from 0 to infinity, this improper integral e to the negative st times e to the kt. Well, that's e to the negative t times s minus k. Think about how that would work out. You know, because you would add these exponents together, but the t factors out, and so it is what I just said. So then we would have, when you integrate that, the s minus k is like a constant because t is our variable of integration, so it's negative 1 over s minus k times e to the negative t times s minus k, evaluated between 0 and infinity. So put in infinity, that's e to the negative infinity, so that's going to be 0. Put in the 0, that's e to the 0, which is 1. So it's 1 over negative of 1 over s minus k times 0 minus 1, so it's just 1 over s minus k. So the Laplace transform of e to the kt is 1 over s minus k. Of course, let's do another one. So let's find the Laplace transform of sine of 2t. Well, we're going to have to integrate by parts. The improper integral from 0 to infinity, e to the negative st times sine of 2t dt. So u is sine of 2t, dv is negative e to the st dt. du is 2 times cosine of 2t dt. And v, integrating this, is negative e to the negative st over s. So we have this integral, our original integral is uv, that's this part, minus the integral of v du, but notice we got another negative on that, so that makes it plus twice cosine of 2t e to the negative st over s dt, and using parts again, this time we would say u is cosine of 2t, that's this part, and dv is e to the negative st over s, and du is negative 2 times sine of 2t, of course that's the derivative of this, and v would be, well, we'd have to integrate this animal, so that would be negative of e to the negative st over s squared. So, what do we have now? Well, our integral is negative 2 cosine of 2t, that's the uv, right? Here's u, here's v, right? Times e to the negative st over s squared, and then minus, which is actually, believe it or not, a triple negative, because it's minus from the formula, it's minus from v, and it's minus from du. So minus the integral of v du, we wind up with the 2 and the 2 from this and the 2 that was in front of our main integral way back when, make that be negative 4 over the s squared, which is from here, and then times the sine of 2t from here, remember v du, and here's the v with the s squared factored out. So, wow. So now we're going to be able to get this one by adding, where, see, we got the same thing on this side of the equation as we do on this side of the equation. So, add this to both sides. We got 1 plus 4 over s squared times the integral we're seeking is this, evaluated between 0 and infinity. And then when we evaluate that, I think you can see where we get, well, put in infinity, we got negative 2 times cosine of twice infinity. Well, I don't know exactly what that's going to be, but when I put infinity in here, I'm going to get 0, so that's going to go away. We won't have to worry about that. But when I put in 0, cosine of 0 is 1. So this is negative 2 times 1 times e to the negative st over s squared. So it's just negative of negative 2 over s squared. So we wind up with 2 over s squared divided by this, which gave us a nice, you remember what that's called? Complex fraction, multiplied by s squared over s squared. Multiply this by s squared, we get 2. Multiply this by s squared, we get s squared. Multiply this by s squared, we just get 4. And so the Laplace transform of sine of 2t is 2 over s squared plus 4.
Heavens to Betsy.
Yes, that's pretty good, isn't it? So, do you understand how that went?
Oh, I see.
Well, I'm glad you see. So, more later.